Food. Many of us take it for granted. Huge food superstores offer us rows and rows of thousands and thousands of different choices. And often, the only difficulty associated with preparing a meal is tearing off the cardboard cover and setting the microwave's timer. But before food ends up here, it starts out here. Whether it's the wheat in your pasta, the lettuce in your salad, or even the sugar in your ice cream, its ultimate origins came from the ground. Just as our bodies require the nutrients in food to keep it healthy, strong, and alive, so too do the plants we eat depend upon the nutrients in the soil to help them grow and survive. The elements of nitrogen, phosphorus, potassium, magnesium, calcium, and sulfur are found in relatively large quantities in the soil and are considered macronutrients. The elements of iron, manganese, copper, zinc, boron, chlorine, cobalt, and molybdenum are found in relatively small quantities and are considered trace elements or micronutrients. The availability of these trace elements is determined by another important factor of soil composition, the pH level. Ranked on a scale of 0 to 14, with 0 being the maximum acidity and 14 being the maximum alkaline, water is ranked at 7 and considered neutral. Dr. Niall C. Brady, one of the world's foremost soil experts and authors, explains why the pH factor is so important in agriculture.
The availability of plant nutrients is determined very largely by the pH. And under very acid conditions, some of the nutrients like iron and manganese become available in such high quantities that they become toxic to plants. On the other hand, at high pH values, those same nutrients become so low in availability that they are deficient, and you get iron deficiency. The two major factors that cause soil to become acidic are reactions going on in the soil as organic matter residues are decomposed and as fertilizer reacts to provide hydrogen ions. That's factor number one. Factor number two is the amount of rainfall that you have, because rainfall removes from the soil the calcium, magnesium, and other base-forming cations, leaving the hydrogen behind to give the acidity. The pH of soil can be controlled by seeing to it that you add lime when the pH value gets down too low. Lime being limestone is the common compound, calcium carbonate, and that replenishes any calcium and magnesium that may have been lost as a result of leaching. So limestone helps you keep the pH moving up into the range that you want it to be. In the western part of the United States, you want the pH to be lowered rather than to be increased. And so you can use sulfur as a means of bringing about that change. The sulfur oxidizes, or is oxidized in the soil by microorganisms, and sulfuric acid forms, and that as a result brings the pH down, makes the soil more acid. But limestone and sulfur are two very common chemicals that can be used to control the pH, make it either go up or down.
Although the role of farmer has remained traditional in many senses, science and technology have played a key role in changing the way farmers grow crops. Today, sophisticated farming equipment can be computer programmed to do a variety of different jobs, while satellite technology is being used to determine areas of a field that may be lacking in specific nutrients. As a result, farmers have teamed up with chemists, physicists, mineralogists, and other scientists who specialize in managing soil to help them yield maximum crops as well as conserve the soil for future generations.
To measure and maintain the pH of the soil would require first testing. It doesn't matter whether you have a small flower bed or a large field. You'd want to get a representative soil sample of that soil area, they have some home kits, but commercially we use laboratories that measure this, and they would come back with a reading, and this reading would determine by the texture of the soil, the type of the soil, and the reading of the pH. Here's an example of two kinds of soils. This one's been amended here with organic matter, also some pieces of vermiculite and whatever for drainage, but this allows, as you can see, it's crumbly and allows for good drainage and maximum growth. This, on the other hand, is a soil that is quite high in clay and has caused to ball up and harden. This is a soil that would not take water as well, and therefore have trouble leaching, and would also probably be higher in pH. When you get to more acidic or more basic, the things that affect soil chemistry or around the root zone are nutrients, structure, and things that the metabolism. So therefore, outside of that range, a lot of times it affects acidity or alkalinity can affect the solubility of nutrients, and therefore some nutrients become unavailable at either end of the range, and so and some become more soluble and can become toxic, like in the case of aluminum. Also, you can have a direct problem with the acidity on the root cells itself for inhibiting the uptake on some acidic soils.
While many scientists focus their talents and energy on agricultural growth and soil conservation, other scientists have focused their attention on another factor that affects the growth of plants: acid rain. Acid rain is a result of oxides being emitted through the burning of fossil fuels. Oxides such as nitrogen, sulfur, and carbon combine with moisture to produce nitric acid, sulfuric acid, and carbonic acid. When these acids combine with rain and snow, they become what is known as acid rain. If the pH in rain or snow falls to 5.5, it is considered acidic. Currently, rain and snow in Europe and the United States commonly falls as low as 4.5 to 4.0.
Humans burn gasoline, they burn trees, and the sulfur compounds and nitrogen compounds that move into the atmosphere are oxidized, and nitric acid and sulfuric acid are formed, and those come back to the earth in the form of water. We call it acid rain. Now, it's important as a acidifier everywhere, but particularly is it important in the forested areas, because forested areas cannot be treated easily and economically with lime, as would be the case in agricultural areas. And as a consequence, you really have no ready means of combating this acidity. And we find in the United States and in Europe that forest growth has been stunted. And many people believe that this is due, at least in part, to this acid rain that's bringing about greater acidification, and with the rainfall also leaching some of the calcium, magnesium, and other such cations out of the soil, leaving hydrogen and aluminum at levels that can be toxic to the growth of the forest trees.
Agriculture. It is the lifeblood of our world. Between us and starvation lies only a thin layer of soil. Soil that once cultivated can feed, clothe, and shelter an entire world. But just as humans depend on agriculture, agriculture depends on science. Science that, when utilized by humans, has the power and the capacity to keep us alive.